Hi everyone, in this video we'll see how to find the present value of ordinary annuities and annuity dues. So now we will do the same thing as we did with future value. So imagine you pay $100 at the end of each year for 3 years. So we want to know what is the present value of all those payments. Instead of looking for the future value, now we want to know what is the present value of all those payments. Imagine that you will get this payment, like you get $100 for at the end of each month, for or at the end of each year for 3 years. You want to know what is the value of those payments today. So the present value, sorry, here it is present value, not future as it is written here. Okay, so it is corrected now. So the present value is actually taking the all those payments from the future to the present. So we bring back this payment to here to the present, bring back this one to the present as well, and this one to the present. How to do this? We know that the present value equals future value divided by 1 plus the interest power t, which is the number of periods, or future value times 1 plus interest power minus t, or minus n, which is the number of periods. So for the first one, this one, how to take it back to the present, it is the present the payment, which is the future value. This payment will happen in the future after one period. So to bring it back to the present, we divide it by 1 plus the interest power 1, which is 1 period. For this one to bring it back to the present, we need to divide this payment, which is future value, divided by 1 plus the interest power 2 for 2 periods, and the last one for 3 periods. Same thing as we did with the future value. So we take 100 as the common factor here, and so we get this, and we have here, if you check it here, we have actually a geometric series. It is a geometric series with the first term here. This is the first term, which is 1 divided by 1 plus the interest, and the ratio is 1 over 1 plus the interest as well. So we can write it like this. So for all this part, it is 1 divided by 1 plus the interest power 1 plus 1 divided by 1 plus the interest power 2 plus 1 divided by 1 plus the interest power 3, which is now the first term. Since this is the same thing as this, and if we use our formula for the sum of all terms of this geometric sequence, we get this. The first term is this one, we saw this, times 1 minus the r, this is our ratio, power the number of period, which is 3, divided by 1 minus 1 over 1 plus the interest, and in the end we will get this, which is 1 minus 1 over 1 plus the interest power 3, which is the number of period, divided by the interest. We can then write our formula like this. So the present value of ordinary annuities is the payment, because it is this times, actually it is this times 100, which is the payment. So the present value of ordinary annuity is the payment times 1 minus 1 divided by 1 plus the interest power n divided by the interest, and we can write it like this. It is the same thing, so it is better to write it like this. So the present value of ordinary annuity is the payment times 1 minus 1 plus the interest power minus n divided by the interest. Now let's see for the annuity due. The same thing. The only difference here is that the payment is made at the beginning of the period, which means here if you get this payment, the first payment you will get it at the beginning. So we to find the present value here, we need to take or to bring back all those payments to the present. The first one is in the present, so there is no period to bring it back. So the number of periods here is 0, so 100 divided by 1 plus the interest power 0, which is this one is 1, plus 100 divided by 1 plus the interest power 1 for this one, because we take it back for 1 period. Here we take it back for two periods, and in the end we get this. So we have this as a common factor. Then we can the same thing, we have here a sequence, geometric sequence. We use the formula that the sum of all term of this sequence, we have the first term here is 1. The 1 is the first term here. This is the first term of this sequence, which is 1, and so it is 1 times here, this is 1 minus the ratio power n, the number of periods, divided by 1 minus 1 over 1 plus the interest. And all this, if we multiply it by 1 plus the interest divided by 1 plus the interest, here we get this 1 plus the interest times all this, which is actually the present value of ordinary times 1 plus the interest. So it is the same thing as the ordinary, but compounded for 1 additional period. So we just multiply it by 1 plus the interest. Also here we can write it like this. We can write the present value of annuity due like this. So it is the payment times 1 minus 1 plus the interest power minus n divided by n, and all this times 1 plus the interest, or we simply can write it like this. This is the present value of ordinary times 1 plus the interest, compounded for 1 additional period. Now let's see an example. Let's suppose that you agree to pay 2,500 at the end of each year for 5 years, and the interest rate is 8%. What is the present value, and how much money could you borrow today if you make these payments? So this is the same question actually. So what is the present value? When I ask you to find the how much money could you borrow, it means find the present value. So we apply our formula, present value of ordinary, because it is made at the end. So it is the P, payment, which is 2,500 times 1 minus 1 plus the interest, which is 0.08 power minus n here is 5 years, and so n is 5. Let's replace with numbers, and we get this 2,500 times 1 minus 1 plus 0.08 power minus 5 divided by 0.08, and we get 9,981.77. Now suppose that the payment is made at the beginning instead of at the end. So this is the formula for present value of annuity due. So it is the same thing as the ordinary, we compound it for one additional period, so we multiply it by 1 plus 0.08, and we get this result. This is the result of, so this is our result. Actually it's 10,780.31, which is greater than the present value of ordinary annuities. And now let's see other periodic payment different than year. So here, suppose you agree to pay $500 at the end of each quarter, not years, for 3 years, and the interest rate is 6%, which is nominal compounded quarterly. Now let's find the present value. We have the same formula, we apply the same formula, but here we have n, which is different. It's not number of years but number of quarters, and the interest rate also, we need to find the quarter interest rate. How to do this? So for the n, it is m times t. So m is the number of compounded, the number of period compounded per year. We have 4 compounding per year, so we have 4 times 3 years, which is 12. We have 12 quarters actually. For the quarter interest, since this one is nominal, we apply that, we divide directly by the number of quarter, which is the nominal divided by 4, and we get the quarterly interest rate. We just need now to apply this here. This is the interest, and this is, and it is 12. We have this formula and we get this result. So the present value of those payment is 5,453.75. In another word, that's the loan that you can get for those payment. So this is what you get today, and so this is it for the present value of annuities. So thank you for watching, and the next video will be about the bond, or the bond, how to find the dirty price and the clean price and accurate interest for the bond, or the market price of the bond. So thank you for watching and good luck.